Hi everyone, welcome back to the channel. Today let's solve the median question from the weekly contest, where will the ball fall? For this question, we're playing a game. We have a 2D grid, 2D matrix that represents a box. And we have n balls on the top, and the box is open on the top and on the bottom side. And each cell in the box has a diagonal board spanning two corners of the cell that can either redirect a ball to the right or the left cell. And the board can have two directions. One is like the first cell in the matrix that spans from the top left corner to the bottom right. And this direction of board can redirect the balls to the right cell in the next row. And this will be represented as 1 in the grid. And the other board direction, like this one, it spans from the top right corner to the bottom left. And this will redirect the ball to the left cell in the next row. And this is represented as -1 in the grid. So we start the game by dropping all the balls on the top on each column. And each ball can get either stuck in the box or fall out of the bottom. And the ball will get stuck if it hits a V-shaped pattern between two boards, like the V shape here or here, or if the board redirects the ball into either left or right wall of the box. And finally, we have to return an answer array with size n, where each element in the answer array is a column index that the ball will fall out of the bottom. And if the ith ball will get stuck in between, then we will put a -1 in the answer array. So for this example, only the first ball, ball 0, it is able to fall out of the bottom, and it will fall out from column 1. And ball 1 to ball 4, they will all get stuck. So the output will be 1 and then -1 for the rest. And the intuition to solve this question is pretty straightforward. So we just drop the balls and then check at every row if they will get stuck or fall out of the board. And the key condition to check this is if Cnext is smaller than 0 or Cnext is bigger or equal to the column length, or if grid R Cnext is equal to negative grid RC. This means that the neighbor cell, they have opposite slope, so they will form a V-shaped pattern. So they will get stuck here. So if this key condition satisfied, then we will know that the ball will either fall out of the board or get stuck in this cell. The time complexity of this approach is big O of m times n, which is square time. But given the data constraint of this question, the length of row and column will not be larger than 100. So this approach will work. Now let's look at the code. Okay, and first is to generate the answer array. And it will be initialized to the range of number of the column length. And this represents the column index of each ball. And next is to iterate through the matrix. And C is the current column index of each ball. And if C is equal to -1, then we know that this ball is already stuck somewhere. So we will just continue this loop. And Cnext is the next column index that the ball will be redirected to. And here is a key condition. So if this condition satisfied, then we will know that the ball will get stuck. So we will update answer I to a -1 and continue. And lastly is to update the column index of each ball. and return answer array at the end. Now let's see the code in action. Okay, and for this example, we have 5 columns. So we will initialize the answer array to an array of 0, 1, 2, 3, 4. And this element represents the initial column position of each ball. And then we start the game and drop the ball. So in the first row, we can immediately see that the ball 2 and ball 3, they will get stuck here because there's a V shape. And ball 0, 1, 4, they are able to make through to the next row. So the next row, the answer array will be updated to 1, 2, -1, -1, and 3. And here again, we can see that ball 1 and ball 4, they will get stuck here because there's another V shape. So next row, the answer array will become 2, which means that ball 0 is now at column 2, and then -1 for the rest, which means that ball 1 to ball 4, they'll all get stuck. And then we'll keep dropping ball 0. So in the next row, ball 0 will be at column 1. And the next row is column 2. And at the end, ball 0 will fall out from column 1. So the final answer to return is 1 and then -1 for the rest. And this will conclude the algorithm. Finally, let's review. So the intuition to solve this question is a straight implementation. We just drop the balls and then check row by row if they will get stuck or fall out of the board. And this is the key condition to check this. And the time complexity of this approach is square time. And the space complexity, if we don't count the answer array, then it will be a constant. No extra space is needed. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.